Good morning, I'm Bryan Griffen. I'm the head of electrical and automation engineering for Nestlé at our global headquarters in Switzerland. I'm also the chairman of the OMAC packaging work group, and I'm here at Pack Expo this morning for the unveiling of a new system that we are demonstrating here at Pack Expo that shows the value and the benefits of PackML in a real demonstration to show how it can be used for end users, machine builders, technology providers, and system integrators, and the benefits that they can receive from using PackML in their implementations. So what we have here, I'll give a quick walkthrough of the machine, is we have 4 separate machines in this demonstration unit. The first one is a destacking unit, which is powered through a Schneider Electric PLC. It takes pucks and places them on a conveyor. The second machine that we have is powered by a Siemens PLC. It reads the RFID chip that's embedded into the puck. If it's a black puck, it turns that puck over so it's upside down. If it's a red or white puck, it lets the puck go through the system. The third machine on the back side here is a Rockwell-powered machine that takes that color information. If it's a white puck, it drills a hole in the center. If it's a red puck or a black puck, it lets it go through to the discharge unit. We then come to the front machine here, which is a Stöbli robot powered by B&R. It takes the pucks from the discharge unit and palletizes them by color, red, white, or black. And if it's a black puck, it turns it back over so that it's right side up. It then, when the pallet is full, it takes the puck and it places them back into the stacking unit and the process restarts. So it's a continuous process. It's not high speed. It's not meant to be high speed. We're not showing packaging capability here. What we're showing is automation capability. So there's a few things that I want to describe to you that make this system unique compared to other systems that we typically see in the packaging world. First off, you will have noticed there were 4 different PLCs involved in this system. So 4 different automation platforms. And yet they're operating on one single communication network. So what we have is 4 different PLCs with 4 different technologies implemented in those PLCs, all using PackML. To get the system to work together, we needed to have a common communication platform. So we chose to use Ethernet, standard Ethernet, with the Weinsteffen protocol. Weinsteffen is a protocol coming out of the brewery industry in Germany. We chose that protocol because each of the 4 technology suppliers already had the drivers for that communication protocol on standard Ethernet. So what we have that I want to show that's different from what you would normally see in a packaging system is the fact that we can communicate on that protocol to each of these 4 different PLCs without the need for a line integration PLC. Now, one thing I want to state up front is we're not suggesting you don't have a line integration PLC. Any real packaging line, you're going to have a line integration PLC and you're going to have to do integration. This is a demonstration to show that we can communicate with a standard across different automation platforms. So we don't have an integration PLC in this particular system. What we have then is, for example, speed information, which is set at the Schneider PLC. That's the start of the system. The Schneider sets the speed and then it transmits that data to each of the other machines and they follow the speed. Color information, for example, is only read at the Siemens Center, where we have the RFID reader. But the Rockwell and the B&R machines also have to know what color the puck is in order to do their operation. So that information is passed from the Siemens to each of those other machines using the Weinsteffen protocol, using pack tags within the PackML standard. We also send a lot of other information around the system, for example, what state each machine is in. If we have an error, the error shows up on each of the different HMIs. So the HMIs are associated with the controller, 4 HMIs from 4 different technology providers. But, for example, if I have a problem with the Schneider system, the stacker gets jammed somehow, I can be standing at the Rockwell system and it will show me where the error in the system is and what the error is. So that from an operator standpoint, I don't have to run all the way over to another machine to figure out what's wrong with my line. I can get my error messages and my warnings anywhere from any of the HMIs, and it does that because they're all using the same tag-based information from machine to machine. So that's the first thing that we wanted to prove, was the fact that with the PackML standard, we can communicate machine to machine regardless of what technology is being used. So part of the value of this system using pack tags and PackML is the ability to have an overall line integration SCADA system that shows what's happening on the line at any given time for any given machine on the line. So what we have here is an overview of the machine. We have the 4 modules, the stacking module, we have the RFID turning module, we have the ejection module, and we have the robot that picks and places onto the pallets. And what you can see is the state model, the state that each of these different machines happens to be in at any given time. So the operator can sit and he can watch this screen and he can see immediately if he has any issues on any of the machines in the line. Other information and value that he can get from this are things such as reporting. This particular report is a run from yesterday showing that everything was in a stop mode to start. Once we started the system, you can see red means stop, yellow means I'm waiting for something, and green means I'm running. You can see very quickly what the bottleneck machine is. It's the robot in this case. At a quick glance, the operator can see what kind of performance and efficiency he's getting. He can find out where his bottlenecks are. He can find out where the errors in the system are happening the most. Where do I have the most red bars? You can see here it's on the stacking unit. So it gives the operator a very quick view of what's going on in his line. Other things that we can do with the HMI would be things such as diagnostics, alarms and events. We can bring in specific data about each one of the different machines and where it's going, what's happening with it. We can do individual statistical reports on each machine, all from one central location using the PackML state model, using the pack tags, and following the PackML standard. All right, we've gone through the operation of each of the different modules within the demonstration unit. But why did we do it? What's the value that we get? Well, by using PackML and the pack tags and all of that standard, we've shown that we can communicate from machine to machine without having to have a system integrator get down into the guts of the PLC code. They don't have to start looking for the permissive bit in this PLC to connect to the permissive bit in that PLC. They just use the pack tags. The pack tags help synchronize the machine, make it more of a connect and pack or a plug and pack sort of a system. That brings a lot of value to all of us in a few different ways. One way is the OEMs now aren't worried about having to give the system integrator all of their code information. They can protect their IP a little bit because a system integrator no longer needs to get into the guts of the PLC to understand how the PLC is working, why it's working that way, so they can integrate it. All they need are the pack tags. It also allows us as an end user to be able to back up a little bit and not be so dogmatic about the hardware solution that we insist on using. Instead, we can say, use the hardware platform that best suits your purpose, machine builders. Give us a machine that does what it's supposed to do the best way that it can. But use a standard. Use PackML so that we can take that machine that may be a completely different automation platform and make it work with the other machines around it. So it allows us to back off and get the better machines. It allows machine builders to focus on innovation. Focus on what makes their machine different from somebody else's, what makes their machine better, rather than trying to figure out how do I make my machine work on this automation platform that my end user wants that I don't know. So in the end, it benefits all of us. It also opens up the doors to the technology providers to sell their systems to more OEMs, to prove to the OEM why he should be using their automation platform rather than saying, well, my end user wants my platform, so you need to use that platform. And say, you need to use my platform because it's the best, and here's why. So we've shown now how PackML can be used to benefit all of us at a machine automation level. But that's down into the machine automation. How does it help the operator? Well, that's where Nestlé is taking this to the next level. One of the things that we have done is we've given a specification for what a standard HMI should look like for the operator. Now, this is not an automation task. This is being done in conjunction with our packaging engineers and our operators. What do they want to see in an HMI? How do they want to control their line? So we created this specification or template for HMIs, and we gave this template to each of the 4 different PLC suppliers that were building their machine. And we told them, use this template to create your HMI. They went away, they did all their programming, came back to us, and you can see Without any interaction with each other or with us, the HMIs look very similar by following this standard template. So we have the same sort of alarm bar at the bottom. We have a command bar for working through the menus. The commands all have the same names, the same positioning, so that you only have to train an operator once on the navigations of the system. After that, he can navigate through any of the different machines. Yes, he needs to learn how the machine works, but navigating to the different parts of the HMI is simple because it's consistent. He knows where to get to the recipes. It's the same place all the time. He knows where his diagnostics are. It's always in the same place. He knows how to change the speed of the line. It's always in the same place. So it brings a lot of value from an operational standpoint in being able to move operators from position to position, and they still understand how to operate the machines. In conjunction with that, we also standardize the light stacks. So we have a standard color coding that tells you, the operator, what is the status of my machine. So he can now stand back, he can look at the entire line, and when he sees a flashing red or yellow, he knows what that means. He knows that a machine is now in a different state. It's no longer executing. And he knows what that state is, and he can come to any HMI, and it will tell him what that alarm is. So if I have an alarm on the other side of the machine, this HMI that's a Rockwell HMI, even though that's a Schneider PLC, will pop up what the error in the system is. So from an operator standpoint in a real line, I don't have to go all the way down to the end of the line to see why the system is in fault. I can look at the HMI that's in front of me. And I can do that because I'm using pack tags. I'm using a PackML state model, so that each machine understands what condition the other machines are in and what fault information there is. Through this demonstration, we've shown the value and the benefits that can be achieved and attained by system integrators, end users, machine builders, technology providers through implementation of an international standard, PackML. Progressive machine builders and system integrators around the globe are already implementing PackML systems. End users such as Pfizer, Nestlé, and Procter & Gamble are already specifying PackML as the standard for their new machines. Now is the time for you as well to have a voice, to be heard as we go and change the way that packaging automation is seen.